Question number 2 of the PhilNITS FE morning portion of the exam. In this question, we are given this situation where 5 people are sitting at a table in a restaurant. 2 of them ordered coffee and the other 3 ordered tea. The waiter forgets who ordered what and puts the drinks in a random order for the 5 persons. What is the probability that every person gets the correct drink? Okay, this question proved to be too difficult for me. I think that I ended up choosing the wrong answer because the correct answer is supposed to be C. I think the technique that I did to at least arrive with one answer, like letter B, is the technique that I guess most people would do if they didn't know that there's supposed to be a formula that you are supposed to use in this type of problem. Although in my case, I may have encountered that idea as well, except that actually I think I did encounter that formula, that equation. It's right here. Previously, when we were doing things related to combinations and permutations, but I think after many years, over 10 years later, I couldn't remember the formula anymore. So what I did in this case is to see what I can arrive at if I tried to think about how I would go about solving this problem. Would I arrive at an answer that's in the choices, in the answer group? And so what I did was to look at what are the givens. We have 5 people, and 2 of them ordered coffee, 3 of them ordered tea. The problem is the waiter mixed up the the items, so we want to know what is the probability that they'll all get what they ordered. And if we think about it, if there are 5 people, so we got 1, 2, 3, 4, 5, and 2 of them should get coffee while the rest should get tea. Now, if we look at the possibility of, for example, just one person, we know that, as we can see here, it's either coffee or tea, right? And I thought that if a person could have either coffee or tea, then there is one of 2 possibilities that the person would get what he wants. Although right now I'm thinking that looks like there would be more cases when you get tea, because it looks like it's skewed in one type of drink, which in this case you get 3 teas and 2 coffees, right? But the idea that what we want is per person, what is the probability that he'll get what he wants, right? And if we're only choosing between coffee or tea, then it looks like we got one of 2 possibilities. Now, of course, later on, I thought too that, okay, so if we got coffee already, then there should be only one coffee left that we can choose from, right? So that's why you'll see that I did some kind of subtraction later on. But if we go first with the idea that a person could have either coffee or tea, and so it could be like this, and then the second person would again also have the probability of getting a coffee or tea in the same way that the first person also did. And so if we have to put them together, we get something like 2 times 2, right? Because if there is a possibility of coffee or tea for one person and then we are adding another person, then we want to know what are the possibilities or the chances of them getting what they want, then it looks like it is 1/4. Okay. Now, if we're adding another person, then if we just continued with that idea without really thinking about that there's only 2 coffees here, then we would end up making this type of equation and this type of computation. So we just increase the numbers, and what we get would be 2 times 2 times 2. The third person would get either coffee or tea, and then the fourth person coffee or tea, fifth person coffee or tea, and if we put them all together, the total would be 32. The thing is, there's no 32 in the answer group. We do have 30 here, and I thought that, okay, so it looks like we need to find out what it is that we need to do some more to get hold of an answer from the answer group. And then I saw that, like I was saying a while ago, there are only 2 coffees and there are 3 teas. Okay, so if we multiply them in this way, 4, and we get 4 and 8, right? And then I was looking for a way to get hold of an answer, and I thought that if we're going for 20, how do we get 20 from 32? And it looks like 4 and 8, if we add them up, we get 12, and subtract 12 with this one, we get 20. So I thought that looks like that might be the way to go. So at least we get an answer. And I think the reasoning behind doing a subtraction, other than the fact that we'll get 20 here, which is among the choices in the answer group, is that I think that 32 symbolizes all the possibilities, right? But we don't need all the possibilities, because we know that in this case, for example, there's only 2 coffees and 3 teas. So we need to reduce the number of possibilities. The thing is, it looks like when I was doing this image file, I also couldn't quite understand why I need to do subtraction. Maybe I think if I went with 12 here and somehow came up with 10, that would have gotten me the correct answer, because the correct answer is 1/10, right? Because this one gives us the number of possibilities if we got 2 coffees, and then if we got 3 teas, then it would be like this, right? So somehow in the end, I just wanted to get hold of an answer that I could arrive at based on some kind of reasoning, some kind of logical computation. And then I also tried out several things uh, to see if maybe there's something that would really tell me that this is indeed the correct answer. And for example, well, if you got 2 coffees like this, and if there's only one person, then the person would get what he wants, one in the 1/5. So what that means is, um, if there are five drinks, then he would get what he wants, one out of a total of 5, right? And then if the second one is like that as well, we gotta subtract 1 here so that we know that the first guy already got what he wanted, right? And then I thought that, how do we put them together? And maybe we can do something like this: 4 plus 5, but this is 9/20, and it's not among the choices. So in the end, I had to look it up. I think that this problem is not gonna be one of those where you can logically solve it in a way that uh, the ordinary guy could do it without the formula, the equation, in this way that we can see, and then that we can plug in the values fairly easily. So in this case, what I found was we do have an equation, a formula to compute the answer in this case, and it's this one, n factorial divided by r factorial multiplied by n minus r factorial. And from here, if we plug in the values, there are 5 people, so n would be 5, and the coffee would be here, and we need to get the remaining t's, and that's why we get 5 factorial over 2 factorial times 3 factorial. And if we put them all together, what we'll get would be 120 divided by 12, which is 10. And if we look at the answer for letter C, that means that 1 out of 10 possibilities will get the right answer. And I got this equation from maths, so it's really mathsisfun.com, particularly the part about combinatorics with the combinations and permutations explanation. So the correct answer is letter C. I think that, well, that's why we're doing the reviews. So if you forgot about this, or you don't quite remember what it is as well, you can look it up and refresh yourself and see if you can get it the next time around.